So section 1.3 deals with transforming a vector from one coordinate system to another. So if we know what the vector r is, let's call this r1 in terms of coordinates x1, y1, and the z component, which will have a 0. I want to know what r1 prime is in terms of its components x1 prime, y1 prime, and the z component. Now really what this is all about is projecting the vector onto the different axes. So to find the coordinate of this vector along the x-axis, take a line from the tip of the vector and project it down so that it intercepts the axis at a right angle. In that case, this leg of this triangle gives me the x1 component. Same thing with the y component. Project a vector or line from the tip so that it intercepts the y-axis at a right angle, and then this distance right here is going to give me the y component. So really, in trying to find the x prime and y prime coordinates, what I need to do is project this vector onto the x prime axis, and then the length of this side of this triangle is going to give me the x1 prime vector. Again, projecting this onto the y-axis, this leg of that triangle will give me the y1 prime. Now, before I actually get started, let's try two simple cases. In the first simple case, we're just going to assume that the vector lies along the x-axis. So here is my coordinate system. There's x, there's y. Here are my rotated coordinates, x prime and y prime, rotated at an angle theta. And here is my vector that lies along the x-axis, and I'm going to call this x1. And this is intentional because this is really going to be related to how to transform the x1 component into these other two vectors. Now, what I need to do is project this vector onto the x prime axis. So draw a line from the tip so that it intercepts the vector at right angles. And notice that this now makes up a right triangle. This hypotenuse is the length x1. Then my x1 prime component is simply this leg of the triangle right here, which is the side that is adjacent to the angle. So since it's adjacent, I know that the cosine of theta is going to be x1 prime, that's the coordinate or the component along that axis, divided by this vector right here, x1. And from this, I get that x1 prime is equal to x1 cosine theta. Now, to find the y-coordinate, the primed y-coordinate, I need to draw the negative portion of that axis, because when I project my vector onto the y-axis, it actually lies along the negative y direction. Now, through a little geometry, I can see that this angle in here is 90 minus theta, which means that this angle is theta. So the component that I'm trying to find is this leg right here. That's my y1 prime. That's opposite the angle. So from that, I get that sine of theta is, now I notice that this is along the negative y-axis, so I need to put in a negative sign there, negative y1 prime. I want this particular term to be positive, and since y1 prime is negative, I put the minus sign out front, divided by x1. From this, I get that y1 prime is the negative of x1 sine theta. So now I have a way to transform the x component of a vector into the prime coordinate system. So you can guess the second simple case I'm going to consider then is simple case 2. Now we're going to go ahead and lay our vector along the y-axis. So here's x, here's y, x prime, and y prime. There's the angle theta. And the vector that we're trying to transform, we're going to go ahead and call y1. Now, projecting this onto my two axes. Now, if this angle is theta, this guy here is 90 minus theta, which means this guy up here is theta. Since this angle is 90 minus theta, this angle is also theta. So, the x component is opposite the angle, which means that sine of theta is x1 prime over y1, or x1 prime is equal to y1 sine of theta. Looking at the y component, the angle is adjacent to the y1 component, y1 prime component, so cosine theta is y1 prime over y1. Therefore, I have that y1 prime is equal to y1 cos theta. All right, now, in order to find the generic case, I just have to combine my two results. So, x1 prime is simply going to come from this term plus that term. The y1 prime is going to come from this term plus that term. So by looking at these two simple cases, I've figured it out pretty easily. If we had nothing better to do, we could consider a third simple case and look at the z-axis for more generic cases, but you've got better things to do with your time. So, x1 prime is equal to x1 cosine theta plus y1 sine theta. y1 prime is equal to negative x1 sine theta plus y1 cosine theta. There you have it. Now, one way to write this is in terms of vectors and matrices. So, if I want to find the vector x1 prime, y1 prime, in terms of the original vector x1 and y1, well, I can just go ahead and pull these terms out and write them in matrix form. So, cosine theta coming from right here. Then the next term will be a sine theta. This term down here is going to come from this guy, negative sine of theta. And then the lower right term is cosine theta. So this is my two-dimensional transformation matrix.